Mr. Bierschbach's recording. Did they hear that?
All right, yep. A transformation. That's what we're doing all chapter. This chapter is transformations. So we're going to map one figure onto another. The original figure is called a pre-image. The image is what you get after you do the transformation. So a rigid motion is a transformation that preserves length and angle measure. What that means is a rigid motion is a transformation that produces a congruent figure, the same size and the same shape. Is the figure on the right a rigid motion? No. It preserves the angle measure, but since it's smaller, the length is not preserved. So this is no, not a rigid motion.
What does that mean? I don't understand. What does preserves length and angle measure? What does that mean?
That means they're the same length. All their lengths are the same, and all their angles are the
So
same.
it have to be the same size?
Same size. It has to be the same size. They have to be congruent. Same size. Okay. Hey. Shh.
Did I just hear a swear word?
I think so.
It's an accident, guys.
That's what we hear.
Okay. The reflection is supposed to be highlighted there. It had a hiccup, and so it obviously moved.
I even highlighted on the right spot.
So reflection is highlighted, so it's a vocab word.
You also spelled it wrong on the
I spelt it wrong on the paper too. I put OIN instead of ION. A reflection is a transformation that reflects each point in the pre-image across a line of reflection. So I will explain that here in a second. So a reflection is a transformation that reflects each point in the pre-image across the line of reflection. All right. So here we go. Line M. Line M right here is a line of reflection. So we're going to take this and reflect it across that, kind of a mirror image. If a point is on the line of reflection, does it move? No, it stays there. So A and A prime are the same point. A doesn't move. C. What you do is you measure the distance from here to here and go that much further to get to C prime. Also, you have to go perpendicular to the line of reflection. So perpendicular across the line of reflection. You can't just go haphazard any way. You got to go perpendicular. So B, we go perpendicular across the line of reflection. Okay? So, looking at this, how do we reflect it across line L? I'll start with H. H is this far away from R, so you keep going that far across R. Okay? G, we go perpendicular to line L. It's this far away, so we again go that far away. That's where G prime is. We put a little apostrophe on it and we call it prime, not Optimus Prime, G prime. Okay? And this is H prime. And then F goes to F prime. And this should be a reflection. This reflects over to this. It's not perfect, but it's close. When you have a graph, it makes it so it's easier to make a reflection. Okay? Here, we're going to reflect across the x-axis. So, -2, 0, where does that go? The same place. It does not move. It does not move. Where does F go? 0, -3. Right down here. That's F prime. Where does G prime go? 2, -4 is G prime. Where does H prime go? 4, -2. That's H prime. Now, if we look at this, okay? Okay, looking at this point to this point, what's different? The y value has an opposite sign. For this one to this one, y value has an opposite sign. Y value has an opposite sign. What's the opposite of 0? 0. So what you do when you reflect across the x-axis, the y value has an opposite sign. So what would you think would happen if we reflected across the y-axis? The x value would have the opposite sign. So that's what it says right here. When you reflect across the x-axis, the y value has the opposite sign. Okay? When you reflect across the x-axis, the y value has the opposite sign. When you reflect across the y-axis, the x value has the opposite sign. All right? So when we reflect across the y-axis, the x value has the opposite sign. Are we good with that? Okay. All right, so we're going to practice that a little bit here. We're going to go across the y-axis with this. So if we go across the y-axis, A is 3 to the right of the y-axis. So then we go Mia. So A prime has, instead of being at 3, 2, it's at -3, 2. Where's B go? -1, 4. It just flip-flops to the other side of the y-axis. Where does C prime go? 2, 1. The y-axis is our line of reflection. Okay? So there's our reflection. That's what the reflection across the y-axis for that would look like. Okay, let's look at reflecting across the line x equals y. Okay? What happens when we reflect across the line x equals y? Look at these ordered pairs. They flip-flop. The x and the y just flip-flop. When you reflect across the line x equals y, they just flip-flop. Now, when you get to Algebra 2 and you talk about inverse functions reflect across the line x equals y. So this will come up again. So when you do inverse functions in Algebra 2, you're just going to basically flip-flop the x and the y values between the two, okay? Which makes inverses a little bit easier once you know that fact. All right, so Chandra wants to roll a ball, hit the wall, and bounce back to hit the other ball, okay? So it's like pool. Like you're playing pool, you're going to hit the cue ball here off the wall because there's other balls. Let's say there's a couple other balls in the way here. So you want to hit pool ball B. So you got to bounce it off the edge of the pool table and hit ball B. Okay? So where are you going to aim to so it goes and hits ball B? Well, to do this, what we do is we make a reflection, and theirs is actually a little bit off. Because see how this line is longer than this line? So it should be the same distance across, and then they should go and hit that point. And wherever that point is on the wall, that's how you know where to hit. Okay? All right. So a reflection goes across a line of reflection. If the point is on the line of reflection, it doesn't move. And then it moves perpendicular across the line of reflection. Okay? Couple couple other ones I want to do for you right here. I'm going to graph quick a triangle, and then we're going to go across lines that aren't the x-axis, the y-axis, or x equals y. I wonder if it's raining.
It definitely is. Can I go?
No. All right, so we have the points. A, B, and C. A is at negative 1, 1. B is at 2, 0. C is at 0, 2. I want you to tell me where it would go if we reflected across the line. Reflect across the line x equals 1. What's the line x equals 1? Would that be a horizontal line or a vertical line? The x-axis is a horizontal axis, but x equals a number is a vertical line. Why? Well, let's look at it. X equals 1 at the point 1, 0. X equals 1 at the point 1, 1. X equals 1 at the point 1, 2. All these points on this line have an x value of 1. So that's why it's the line x equals 1. So if we're going to reflect across that line, where would A go to? It right now is at negative 1, 1. What would be the ordered pair of A? Jack, close your lid. Jack, where would it be? You have no flipping clue because you weren't flipping paying attention, were you? Okay? Start paying attention. Then Ray can actually learn something. All right. So, Jillian, if we're 2 away from the line of reflection with A, where would A end up? 2 away on the other side. Do you know what ordered pair that would be? 3, 1. So A prime would be right here at 3, 1. Okay? So it goes from negative 1, 1 to 3, 1. Okay? Where would B end up, Micah? At 0, 0, because it's 1 to the right of the line of reflection, so it'd go 1 to the left of the line of reflection. B prime would be here. C is at 0, negative 2. It's 1 to the left of the line of reflection, so it would go where? 1 to the right. So C prime would be here. So here's the reflection across that line of reflection. Okay? All right. I'm going to throw another graph on the same graph. We're going to reflect across the line y equals negative 2. Where is the line y equals negative 2? Where the C's are at. It's a horizontal line where the C's are at. So if I take the red triangle and I'm going to reflect across there, where does A end up? Where does A end up? Jordan. 3 down from the line of reflection. So, because we went up 3 from the line of reflection to get to A, so we go down 3. There's A prime. Where does B end up, Isaiah? I don't know. You need to pay attention as well. Okay? Thomas, where does B end up? Yeah, at negative 4, because B is 2 above the line of reflection. So you need to go 2 down. C, where does C end up, Caitlin? Same spot. Because if it's on the line of reflection, it does not move. Okay? So You can reflect across other lines besides the x-axis and y-axis or across the line x equals y. You can reflect across any line. So you'll see that maybe in today's assignment. So understand that there are other lines you can reflect across. So now that Savas Realize is up working again, I hope it is.